Hi everyone, my name is Simran Sokhi and I'm a student at Tanglin Trust School in Singapore. As a child, I've always been intrigued by skydivers. I've always wondered what they must be feeling and the different forces that must be acting on them as they jump from such a high altitude. In order to experience the physics behind these skydives, I decided to try it out myself. In order to understand the forces that act on you while skydiving, we first have to refresh our memories on Newton's first law of motion and Newton's second law of motion. Newton's first law of motion states that if the forces acting upon an object are balanced, then the acceleration of the object will be 0 meters per second squared. This can mean two things, either that the object is at rest or it's moving with a constant velocity. The net force can affect the speed, direction, or both speed and direction of the object. In other words, it affects the velocity of the object. Newton's second law of motion states that the acceleration of an object is dependent on two things. Firstly, the net force, and secondly, the mass of the object. The acceleration is equal to the net force divided by the mass. It's important to remember that this net force is the sum of all the forces acting on an object. Let's now go through the various phases from jumping out of the plane to landing onto the ground. As I jumped out of the plane, I was under freefall. I immediately faced the downward force of gravity and started to accelerate at 9.81 meters per second squared. The downward force on me was simply my weight, which is equal to my mass times the force of gravity, which is taken to be 9.81 newtons per kg. As I continued to fall, the air resistance opposing my motion increased. Air resistance is present when an object collides with surrounding air molecules. These air molecules create a force called the drag force, which acts upwards and opposite to the downward gravitational force acting on the skydiver. An increase in velocity causes an increase in the drag force, and this in turn reduces the acceleration until the skydiver achieves an equilibrium and the net force is 0. The drag force on the skydiver depends on three variables: the velocity, the air density, and the surface area of the skydiver. The drag force is directly proportional to all three of them. This means if any of them increase, the drag force increases as well. The drag force can be represented by the following formula. D is the drag force, K is the drag coefficient, the lowercase d is the air density, V is the velocity of the skydiver, A is the frontal area. During terminal velocity, the drag force equals to the weight. Simplifying this equation gives us V equals square root of 2mg over kdA. From this we can conclude that a skydiver can achieve higher terminal velocity in a free fall if he has a greater weight, lower frontal area, and if the air density and the drag coefficient are lower.
Grass is always greener, but how do you know we'll see? Do you still believe in love, I wonder?
The skydiver achieves a second terminal velocity when the parachute opens. This is because the cross-sectional area increases dramatically and the drag force becomes even higher than the gravitational force. This causes a deceleration and a reduced velocity. Due to the decrease in the velocity and the drag force, the skydiver achieves a second terminal velocity. Thank you for watching, and next time you're on a plane, jump out with a parachute.